All right, folks, let's solve some problems. Let's remember Coulomb's law that force equals K, Q1, Q2 over the distance squared. So let's say we've got a Coulomb's law problem, and here's the problem right here. Objects 1 and 2 attract each other with an electrostatic force of 18 units. If the charge of object 1 is halved, then the new electrostatic force will be blank units. Okay, this is my strategy. There's a couple ways to do it. I'm going to call this the QQDF chart strategy, or the QQDF strategy, Q1, Q2, DF. And this is actually a data table that we're going to create. Now, let's see, what did they tell us here? And we're just going to use this method because we'll get it right every time this way. The electrostatic force is 18 units, so let's just write down 18. We would usually use newtons. I don't know why they're using units, but whatever. Now, part of this QQDF strategy, the first step is just to pick numbers. Just a pick number strategy, and let's use the easiest number we know. Let's just use 1. 1, 1, 1. Okay, good. Now, it's asking us what is going to be the new force if, what does it say? If the charge of object 1 is halved, then the new force will be how many units? So, looking at this sucker, charge number 1, I'm going to use these little arrows, is going to be halved. And now it's going to be 0.5. Charge number 2 doesn't change, the distance doesn't change, and we want to figure out the force. Okay, so looking at the formula, remember that force and charge have a direct relationship. Force and charge have a direct relationship. So if charge is halved, then force is also halved. So our new force is going to be 9 units. And that's as easy as this gets. I just like the way that we set this up, just because we'll get it right every time as they get more complicated. So let's look at this new one. Object 1 and 2 attract each other with an electrostatic force of 18 units. If the distance separating objects 1 and 2 is changed to 4 times the original value, for example, quadrupled, then the new force will be how many units? So let's go back. Let's just make the new chart QQDF. It's a QQDF chart. Boom, boom, boom. I'm doing it every time just so that I practice. And guessing numbers, but it actually gave us 18 units for the force. It won't always give us that. So how is the force going to change? Well, it said that the distance is, did it say quadrupled? I think it did. Double check. The distance, yep, is quadrupled, which means times 4. So 1 times 4 is 4. These don't change. So if distance is quadrupled, how is force changed? Well, let's look. The relationship between force and distance is an inverse square. That's something you have to remember. So what does that mean? So here's this new step. How do we figure out an inverse and a square? So let's take this factor, this times 4. Let's times 4. Let's inverse it. Is the same as taking its reciprocal. So inversing, this is an inverse. So when we put it in the denominator now, and then we're going to square it. 1/4 times 1/4 is times 1 over 16. So 1/16. And so we have to multiply 18 times 1 over 16, which is the same as dividing by 16. You guys are getting good at fractions. You could do it on your calculator, whatever's clever. It's going to be 1.125. Let's see if that's the right answer. 1.125. Enter. Check answer. That away. Good. Last problem. So objects 1 and 2 attract each other with an electrostatic force of 72 units. If the charge of object 2 is tripled and the distance separating 1 and 2 is doubled, then the new electrostatic force will be how many? First step, let's make our, oh, I just deleted it. Let's make our QQDF chart. I just invented this, you guys. I think it works though. QQDF chart. It's just a data table, really. And they said that the force was 72 units. And then remember, we're just gonna pick numbers. That's our strategy. It's just a picking numbers strategy. You do it in math all the time. And we got to know the two changes. The charge of object 2 is tripled. Charge is tripled and the distance is doubled. Charge of object 2, it said. Charge of object 2 is a times 3. And then the distance is doubled. Let's do it one step at a time, though. Let's do it one step at a time. That's part of our strategy. So what is the relationship between charge and force? What is the relationship between charge and force? The relationship between charge and force, or force and charge, that's a direct relationship. That's a direct relationship. So if the charge is tripled, then the force is also tripled. That's a direct relationship. So 72 times 3 is 216. Good, now let's handle that second part of that problem where it says that the distance is doubled. So the distance is doubled. So I'm not going to change charge 2 now. I'm not going to change charge 1, but I'm going to double. It said double, right? I'm not making that up. Yep, charge 1 and 2. The distance is doubled. Boom, bing. We got to double the distance here. Now, if the distance is doubled, how does the force change? How does the force change? Well, folks, remember it's an inverse square relationship. An inverse square relationship between distance and force. Inverse square. Inverse square. We see it up here. There's that inverse square. We can see it in Coulomb's law. So let's do that same thing where we take that factor, double, let's inverse it. Inversing it is the same as the reciprocal, 1 over 2, and let's square it. Boom, and we get 1 over 4. 1 over 4. So 216 times 1/4, same as divided by a 4th. We get 54. Let's see if that's our answer. Boom, 5-4. Check answer, data away. That's how you do these, folks. Just remember your strategy. Make the QQDF chart. Remember the relationships. Remember the relationships. Guess numbers. You got it.